Mr. Rattanak. So enjoy together.
Okay, thank you. So let me share my screen. Can you see my screen?
Yes.
Hello. Okay. So let's start. Hello everyone. So thank you for joining in my presentation. Today my topic is about web vulnerability for developer. So before we get started, let me explain you what web vulnerability is. So web vulnerability refer to a system flaw or weakness that happen in your web application. And these kind of weaknesses or flaw could things like making your website go offline, steal your customer data, or data breach your website, which happened quite a lot recently for the past few months. And as a developer, you should have some basic understanding of different type of vulnerability, how does each one web vulnerability happen, and how to protect it in order to write a more secure code for your web application. So because of, for example, if there is some certain type of web vulnerability that happen somewhere in your application, this could allow attacker to or hacker to cause harm or damage to your customer, and also hurt your company reputation as a services that own that web service. Okay, so let's talking about the agenda here. So the first thing is I'm gonna pick some vulnerability that I find interesting and that have and also happen a lot in the web application. So there are gonna be four vulnerability, and there's many type of vulnerability out there that I'm not gonna talk about because we have some limit time, and then I will go through each one by one of those vulnerability and explain how it works, and then I will suggest some way that can use it to prevent that certain type of vulnerability from existing in your application, and then I will guide you on how to test your own web application or for those type of vulnerability. And finally, I will give you some resources for you to get started if you want to know more, if you want to know other type of vulnerability beside this one that I just talked about. So let's start with the first vulnerability. It's called XSS or cross-site scripting. So XSS vulnerability occur when an attacker can execute custom script on a victim browser. So what it's basically mean is that if some functionality in your web application, for example, your login form or register form that is vulnerable to cross-site scripting or XSS, it means that the form or the register could allow the attacker or hacker to inject their own JavaScript code into that form. And if the user view that that register form or login form that's vulnerable to XSS, they will get the attacker script code run on their own browser. So as you already know, in the web, we use a lot of JavaScript code to do many things. And if the attacker could basically run their own JavaScript file on the user web browser, the first thing that they can do is steal their cookie, because if the attacker could steal that cookie, it means that they take control, they have total control over your account, because they don't need to know the password or the username. Only do the only thing that they can do is steal your account cookie, and you're done. And another thing is they can use JavaScript to change the website content, like defacing your website, like if you like manipulate the element in your website. Like for example, if you go to that login form, they can just manipulate the element of that login form to print out text that this form has been hacked or something like that. And the another thing is that the JavaScript can also be used to bypass the same origin policy, which is secure, also a security mechanism that that prevent one side, for example, side A, to read data from side B. So if they can, if the attacker could execute JavaScript on that website, it means that they can bypass the same origin policy. And the another thing is they can also redirect user to another malicious or bad website also. So XSS are divided into three types of XSS. The first one is called reflected XSS, and the second one is called store XSS, and the last one is called DOM-based XSS. So reflected XSS happen when the user input is redirect to the user. So it means that if the user input take the input, and then if there's a functionality like a text input that take the user input, and then it's print out to the user screen, it potentially mean that this login form is vulnerable to reflected XSS. So let me do some demo on how it works. Yeah. CDs. No. Index.js listen localhost. Okay, so let's say query hello. So let's say I have an endpoint here that take the user input hello, and then it tries to search into the database, and then after that it print the result to the output to the user browser. So if this function here, that search function here, is vulnerable to reflected XSS, the attacker might be they can test if that function is vulnerable to XSS. So as we already know, when we want to execute JavaScript file, we would use the script tag. Script alert 1. So what essentially inside the script tag is the browser will treat as a JavaScript code. So this code here will pop up an alert box when we execute it. So if I send the value like this instead of normal string like hello and set enter, I get JavaScript executed on my browser. And yeah, that's what the reflected SSS work. And if, for example, what if I find the reflected SSS on this functionality, the attacker, I can one thing is that I can copy that link and then send it to the user, and when they click that link, I can get my XSS executed on the browser, on the user browser. And yes, that's what the reflected SSS is, mean that take the input and then reflected it back into the output. And the other type of XSS is called store XSS, and this one is actually a lot more impact than the previous one, because this one require the user interaction. The first one requires the user interaction to click on the link, but this one doesn't require the user interaction. So the store XSS is occur when the malicious script store come from the website database. It means that there is some functionality that vulnerable to store XSS, and that function will send the user input store into the database, and then it respond the script back to the user. So I'm gonna also do some demos to make a bit more easy to understand. So this function here, I have function that when I click add, I can add my own product like orange. Then when I refresh, the input that I just give will be stored in the database, and it then show it to the browser. And what store XSS is that when we give the input, the script input that we just show, script okay. So I got also XSS alert. So basically, the script, the script that I just sent, that I just input recently is sent to the database, and it is stored persistently on the database. So every time I refresh, it's gonna get access JavaScript execute on the browser file. So for example, if this page is a public page that anyone can view. So if someone that view by, basically if someone view my page that has store XSS that has a store XSS, it means that their browser is going to execute my JavaScript automatically without any something interaction like that. And the other type of XSS is called DOM-based XSS. So this type of XSS is actually similar to reflected XSS, but what makes it different is that the input of the user don't actually send to the server and then respond back. For DOM XSS, when you send the input, it's gonna stay on the client, and it doesn't go to the server and respond back. So DOM XSS is actually a little bit harder to store to protect because of the user have have no idea to what the user input is, and so you have, in order to prevent it, you have to write a code on the client side to prevent your website vulnerable to downback SSS. So let's go back to 2004, where there is a store XSS vulnerability that happened in TweetDeck. So for those who don't know what TweetDeck is, it's essentially a dashboard that TweetDecks. So it's basically a dashboard that allows you to view Twitter feed without go to the twitter.com, and TweetDeck is vulnerable to store access. So this guy here, Andy, found and store access on TweetDeck, where he could upload the JavaScript file, this JavaScript payload, into the tweet update through TweetDeck, and basically the file works like this. So when other user that view this tweet here through TweetDeck, they got the JavaScript side is going to execute on their TweetDeck account. So the first thing first is that their account is going to retweet automatically retweet this tweet, and then pop up an alert called XSS in TweetDeck and with a heart emoji. So when the user when the another user view this tweet on through on their TweetDeck, it will automatically auto retweet this tweet and then pop up an alert in TweetDeck. So this person here actually, I mean, the JavaScript code here is actually not really harmless, but if what people if bad people trying to do basically different, instead of pop up and alert and retweet, they probably start to want to steal your data or cookie, or even use it to monitor you or something like that. I'm not really sure about that, but yeah, that is potentially the impact of XSS that could impact to your web application. And let's go with the prevention of how we can prevent XSS from happen in our application, web application. So the first thing first is you could set your cookie with an HTTP only flag. So as you already know, if the attacker can steal your cookie, it means that they can take over your account without any password or your username. So if you set the cookie, set the HTTP only on your cookie, it means that the attacker cannot have no way to read the JavaScript, have no way to read the JavaScript, have no way to read the cookie via JavaScript. So in JavaScript, if we want to read the cookie of one of this side, we can use thing like document cookie. Yeah, so because I don't have a cookie, it's not gonna print out. But if we have a cookie that's set with HTTP only on, it means that I cannot use this function here to read the cookie of the user. So the only way that the cookie can be seen is the server, when we send it to the server. If we set the HTTP only on, it means that we cannot use the function to read the cookie of the user. So it's one way to protect your sensitive information with HTTP only on. And the another thing is to use a content security policy header. So content security policy header is basically a header, a secure header that prevent you from executed from JavaScript file from untrusted source. So if you go to this website here called Content Security Policy, and then we see we can look for this value here. So if we define the content header with this value, it means that for every JavaScript file that so basically your website can only execute JavaScript file from a trusted source. So if the JavaScript file come from another website and inject into our own website, the browser will reject that JavaScript file. So what this value means is that only execute JavaScript file that is owned by that is owned by the website, and also JavaScript file that come from js.example.com. So so let's implement the fix how we can use it to protect JavaScript file. Okay. No. Okay. Okay, so in the case of let's say exercise. Got store exercise. Okay, clear data. Okay, so in the case of store access here, we got this page vulnerable to store access. So if we want to protect it from, if we want to tell the browser to execute from only trusted source, we can basically give the endpoint a store header. So here, search. So security policy on with only executed from a trusted source, which is our own website, localhost 8080. So when we go to this website, the web server will respond the code and then also respond with the header content security policy script on. So let's start. Let's test. Boom. Oops. Again. Content security. Jump. Should respond. Yeah. Okay. So when we request to S endpoint, it's gonna have the server will basically tell the browser, hey, only execute JavaScript file that come from this domain only. If there is other JavaScript file that inject into um, this endpoint slash here, you have to deny it. So let's test if our store SSS work. So script script. Okay. Our access is not scripted because of the contents policy had the prevent it from running untrusted JavaScript. So basically what we just do here, what we just execute here is inject the code through inline JavaScript, and um, the contents secure policy only allow um, the only allow to execute when you enable content security policy on the website here, it will automatically disable inline JavaScript. So it means that you cannot write a JavaScript inside the script tag. The only way to you to execute to use JavaScript is by use outline external JavaScript um, like this as link JS file. So that's how that is one way. That another way that you can use content security policy to protect your website from access. So basically you should implement it in your website if you don't have third-party services that integrate in your environment. For example, like login with Google. And if you implement login with Google, you can also specify the value here that to tell the content security policy header to trust any script that come from google.com. And the other thing is the another thing is to escape special character on in the user input. So things like open bracket or quote, and fortunately most modern framework already does that for you. So like React or Vue.js already auto escape special character for you through the use of auto escaping and template using. So if you are using modern framework, you don't have to worry about escaping some special character, which is another attack vector that can potentially use make access happen in your web application. And the other fourth option is to use third-party library like DOM Purifier or anti-access. So this library is that essentially when you can basically give an input to it, and then it will purify it will try to detect the code that might allow the attacker to execute JavaScript, and then try to clean that code to make it more functional. And then the last thing is to blacklist certain tag. Like if the user input contain script tag, you should remove it. But it is not really a good idea way to prevent from the attacker to execute script, because there are many things that the attacker can use to the attacker can execute JavaScript by not using the text script alone. So for example, they can use the body tag and with the attribute of onPrint element, and it can also call the JavaScript function code to execute on your on your web browser also. So it's really not the ideal way to blacklist some certain tag. And so let's talk about how to test for SSS. So the first thing first, if you want to test your application if it's vulnerable to SSS, you can start from functionality that take the user input and then get rendered out onto the page. So things like username, last name, or email, because when you register your name or username might show to the another user when they view your profile. So let's start. So you should start from those functionality first to if they actually vulnerable to reflected SSS or store XSS. And the another thing is that you should use more than a script tag to test if your application is vulnerable to XSS, like as we mentioned before. You can try to use other script tag, design script tag to test if your functionality of application is vulnerable to XSS attack. And also some website they might try to implement a blacklisting like filter out script tag, but they forgot to also filter out the script tag like this. So basically, if they forgot to do this also, you still can get an XSS JavaScript execute on your website too. And the last thing is that if you find an XSS, you can try to make to escalate the attack. It means that you try to make the attack more impactful to the user. So the first thing is that we can use JavaScript to steal the user CRF token and send it to our website. So what is CRF token? So CRF token is basically a token that prevent you from prevent your application from vulnerable to CSRF attack. So what is CSRF attack? So CSRF attack is that it's essentially a type of attack that allow the attacker to request to forge a request and send it to the website on your behalf. So let's say that we have an endpoint like example.com/delete. So if the website example.com here, if the user requests to this endpoint, they will get the account deleted. So what happen if the attacker want to delete the user account? They can create their own website and then copy this link into the website, and then when the user click on the link from the attacker website, they will redirect you to this endpoint and got their account deleted, which why we call it request forgery. So the robust the good method the best way to prevent this attack from happen is to use CRS token to tell to which will generate every time you log in, and then when you try to send a request to the website to the server will try to validate if the CF token is valid or not, and then they will allow you to process that request. So if you be able to steal the CF token, it means that you can embed that token to your website, and then when the user click on the link here on the attacker website, they will redirect to the endpoint and give the CRF token to the server also, then they also get the account delete. So yeah, that's all for the XSS vulnerability. And the another thing, the second vulnerability is called it's called insecure direct object or IDOR. So IDOR happen when the application grant direct access to a resource based on the user request without validation. So what do I mean by that? So for example, if example.com, so so let's consider example.com as a social media platform. So when I register my account on example.com, example.com will assign my ID, assign my user ID with 123. And after that, example.com social media also have a, a feature, a functionality that allow you to see your own private message by go to this link example.com/message, and it take the user ID of of your account. And so other vulnerability occur on this. If example.com has a functionality that let you view your private message, if you go to this URL here and it take the user ID of the user account like 123 here. So what the attacker can do is, what if they change it from 123 to they might have guessed that if my current ID is 123, the ID of the another user that register after me might probably 12345. And if they go change that ID from 123, which is my user ID, and to another user ID like 12345, and the example.com allow you to see the private message of the another user, it means that that functionality, that view message functionality here is vulnerable to IDOR here. So same for post request. So if I want to change the password by requesting to this endpoint here, and it take the current user, the user ID of the current user and the password, and what if I want to change the another user password by increase by changing from 12345 to 123 4 to 12345, and it allow me to change the password of another user. So it's mean that this endpoint, this functionality here also vulnerable to IDOR. So let's take you to some vulnerability that are Instagram video reel. So for those who don't know what Instagram video reel is, it's basically a TikTok version of Instagram. So with Instagram video reel allow you to post a short video of and upload it to the new feed, and also allow you to check of that video reel. So this guy here found IDOR vulnerability that we just talked about on the Instagram video reel, where he could change the thumbnail of the Instagram of another people Instagram video reel with the thumbnail that he wanted to change. So after he found the bug, found that vulnerability on Instagram video reel, he reported it to Facebook, and Facebook fixed the problem, fixed the vulnerability, and reward him with like $49,500. So the process of how that IDOR vulnerability happened on the Instagram reel is actually quite simple. So so the first thing first is that the attacker can go to Instagram newsfeed and browse for Instagram video reel, and Instagram also let you save that video reel if you are if to your account if you want to save it, and once you sell that video reel, Instagram will send a post request to this endpoint here with the ID of the other people of that video Instagram video reel. So one thing that attacker can do after they sell that other people Instagram video reel and get the ID of that people Instagram video reel, they can first create their own video reel and change their thumbnail of their own Instagram video reel. And once they change and then hit send, Instagram actually send a post request to this endpoint here, which take the clip media ID of the video Instagram reel. And what the attacker can do, they can intercept that request using Burpsuit, and then change the ID of the video Instagram that own to the victim that to this ID that they want to change. So when they change and then they click send a request to server, the server actually change the thumbnail of another people Instagram reel. So it's so IDOR is basically IDOR is simple, but it's allow you to potentially do a lot of damage to your application. So for those of you who don't know what Burpsuit is, so basically Burpsuit is a software which allow you to so it's basically a man in the middle software which allow you to intercept the request that sent from one device to the server. So for example, if so example in the case of here, okay. So when we come to the website here, the browser the browser will send a request and the server respond back with without us to be able to stop this request and intercept the request and then change the and then manipulate or change the value of the header to test if that if our web application is vulnerable to some certain type of attack. So Burpsuit is a tool that is popular for web application pen tester to use it to test the website if it's actually vulnerable to some certain type of vulnerability. Okay, so let's go to on how to you can prevent IDOR from happen in your web application. So when we want to fix something, we have to define what our web application file that can occur that can make IDOR happen in our web application. So first, the web application file two things. So first, they fail to implement the access control based on the user identity. So in the case of Instagram here, they let you change anyone thumbnail ID without verify that the ID the video Instagram is actually owned by you, but instead they didn't verify, they didn't check the clip media ID if it is owned by you. So which allow you to change the thumbnail of another people. And the other thing is that web application is failed to randomize object ID and instead keep the reference of data object predictable. So in the case of view profile here, 1 to 3 is guessable, right? Because might go to some functionality and they can make a guess that if the user ID is 123, probably 12345 1235 is probably the next user ID. So IDOR, so because of the user ID here is guessable, it can allow the attacker to change the ID to another number to see if your application is vulnerable to IDOR. So to prevent those from happening in your application, you can first implement user identity. You can implement the user identity and permission before granting access to the resources. So for example, like you can check the section cookie of the user if it's actually corresponded to the user ID that they just sent. And next is that you can try to hash the user ID or ID that is guessable with a secure algorithm and random key. So for example, in the case of 123 here, we can try to hash the ID with another secure algorithm so that it can make the attacker unguessable, so that they can change to the another user ID. But this fix here should be optional. The best one is to implement a good control access on your application, because of is that this user ID here could be leaked, right? Because if your functionality have a view profile function, if you go to that profile, you go to that another user profile, they're gonna show the user ID that of that user profile, so they can copy that ID and pass it to the view message function, and your application still vulnerable to IDOR. So let's go with how we can test for our application for IDOR. So the first thing is IDOR usually occur in the functionality that involve around getting the user data or modifying the user data. So if you want to test your web application for if it's vulnerable to IDOR, you can start with those functionality, modify user data, and return the user data. And when you test for those functions, try to pay attention to parameter that take number or user or ID as an input, because of if you could allow, because if you can change the ID or input of that parameter to another user parameter, you can you find IDOR on the web application. And the another thing is that you can some people they also implement an unguessable ID, but some people they don't use hash to hash the ID of the user, but instead they use a simple algorithm like base 64 encoded, which is for most users, if they see that, it's probably unguessable for them. But we have a tool that can detect the algorithm like CyberChef. If you post a random copy and paste the random tag into this website here, it will try to detect what algorithm what the algorithm behind those words is, and then try to decode it. So in this case, we use base 64 URL encoded to encode the number 123 into this random tag. So and another, so it's still vulnerable to exercise like 1, 2, 3, 4, 5. And the another thing is that look for functionality that can leak ID user. So things like view your profile, view user profile, or endpoint endpoint that get the user ID if you request to it, and and another thing, and another way to test is try to change the request method. Like for example, if we use this endpoint here to get the user image, what if you try to change, instead of get you to change it to delete, if it's actually delete the 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 picture? If it does, it means that it also vulnerable to IDOR too. Or maybe if we have a post request that send the recipe, that send recipe of another user ID to the server, and what if we change, what if we want to get the recipe information from the another user instead? We can try to change from post to get and then give the recipe ID, and if it give the another people's recipe ID, it also vulnerable to IDOR. So yes, so let's go with the third one. The third one is called supply chain attack. So supply chain attack is occur when the attacker slip malicious code or a malicious component into a trusted piece of software or hardware. So basically, it means that your web application is totally fine. Your web application is 100% secure, but what make a supply chain attack occur is that it's actually your dependency. Your dependency is actually vulnerable to some type of attack. If the attacker could take control of your dependency, software dependency, it means that they can it means that your main web application that uses that dependency also vulnerable to type of attack. And so for example, like npm here, they use, so in order for npm to 100% secure from supply chain attack, they have to make sure that each dependency that they use is not does not have any malicious code, does not have any bad code inside that each packet, and each packet doesn't have to be vulnerable to any type of attack. And as we already know, npm use like npm CLI, npm detect, or npm config, and we have to make sure that the npm config also not have contain any dependency that is vulnerable to like attack or contain malicious code in it. So here is the graph of what the total dependency that used by npm. So we can see that it's about like 197 dependencies. So if we want to mitigate from or prevent these from happen into our application, we have to make sure that each packages or each node doesn't. So yeah, so in the recent for about 2 or 3 months, they have not 3 months, like almost 6 or 7 months already, there is a war against Russia and Ukraine, and there is one guy who decided to protest again the war Russia with Ukraine. Which is this person here. So he decided to protest against the war and update his dependence, update his packages, which is Node IPC, and put the malicious code into his packages. So what the code basically does is that if you are a developer person who has his package Node IPC installed in your computer, and you have a geolocation or the geolocation that you live in Russia or Belarus, the code, the node IPC, the node the node IPC here will delete your content of your PC file and replace each content of your PC file with a heart emoji. So if you don't know what a node IPC is, it's basically a dependency that used by many big software like Vue CLI, which is also used by Vue. So if you install Vue and if install Vue, it means that you also install Node IPC as a dependency of it. So if you live in Russia or Belarus and you have Vue installed on your desktop, you're going to get your PC data wiped out with heart emoji. And it also used by other popular software like Unity Launcher, which is also built with Electron and use the Node IPC as the dependency also. So there are also another case for Python packages, which pop up recently around last few months. So there is multiple Python packages that attempt to steal another people AWS secret key, and a lot of people actually fall for it by installing that dependency and got their AWS key stolen. And all this new here is actually some of the story. There are many some of the story of supply chain attack, because of there are many stories that related to supply chain attack, like SolarWinds attack, also software, which is a software that vulnerable, that is also impacted by the supply chain attack last year. And there's many popular npm packages that the maintainer decide to put their malicious code, their malware into the packages and affect many of the user like Color.js or Figure.js. And these actually what also hurt the reputation of open source, right? Because you have one person who have complete control over one packages, and one day they decide that they want to change, they want to put their malware, their code, change their code to malware and affect many people like that. So in the case of Vue, the packages is maintained by the community and is controlled by one person whose name is like what you and through you, and the React is controlled the React framework is controlled by Facebook, and which is a big corporation that thing like this likely to happen, because it's a corporation maintained instead of the community of people maintain these packages. So let's go a bit on how to find and fix it. So the first thing is there's not many clear way on how to fix the dependency supply chain attack. So one thing is that you can try to use a scanning software tool that scan for known vulnerability or a vulnerability that vulnerable to that have a bad code in it. So things like Snack open source scanner, which is a scanning tool that allows you to integrate into your development environment or into GitLab or GitHub to scan the code every time you push the code to the repo. And if there is some supply chain attack code, some code that posts that posts into your dependency that potentially be a supply chain attack, they will try to notify you on how to fix it or do something about it. But the problem with it, with this Snack open source tool, is that they only give you some limited amount of scan. If you scan more than the limit that they reach, you have to pay for about like $80, which is kind of expensive for one person. $80 for one person if you want to continue scanning your source code. And the another thing is free, which is called Dependency Tracker. So what essentially is that it's like a dashboard that keep track of your dependency, and if there is some type of dependency vulnerable to the supply chain attack, that will try to notify you. And the another case is for Go. They implement a beer lock on their dependency list. So if also so that you can update your dependency unless you specify it to update in the Go mod file. And yeah, because of we have, that's all for supply chain attack. So because we don't have much time, I'm gonna go to the resource that I'm gonna recommend you to go from here. So the first resource that I would recommend you is to go to go to OAuth's top 10 website. So what is OAuth? So OAuth is a community, an online community that aims to create resources in the field of web application security. So if you go to their website, they have a lot of resources that that you can look that detail about other type of vulnerability that you can fix it and how to invade the defects. And the vulnerability that I just talked about is also, you can read on their website also if you want to learn more or dig dive into each type of the vulnerability that I just talked about, because I've only explained the basic understanding for you to get started. So OAuth also have a top 10, also have their own, one of their project called OAuth top 10. So OAuth top 10 is basically a project, is a project that basically keep track of web applications most likely occur in around the web application. So as you can see, in 2017, injection vulnerability is the #1 vulnerability that happened in most web application, and they update the list every like 4 years. So as you can see, as the web application evolve into more secure thing, into a secure application, injection like this go down, and broken access control start to gain more popular because of the complexity of the web application grow more bigger and bigger. So broken access control is also an IDOR vulnerability that in the IDOR vulnerability. And the other thing, and the another resource is to go to portspeaker.net. So for those of you who want to get started into this kind of application application testing and don't know where to start, you can, the resource that I would recommend is to go to this website, and they will give you the learning path on where you actually get started. And when you have some basic understanding, you can go to the website and learn more deep dive into each type of vulnerability that you just learn from it. So once you learn from it, let's say that you want to practice this on a vulnerable application. So the first result that I would recommend is to start playing CTF. So what CTF is basically capture the flag. So For example, here we have Google that hosts the CDF, and there's many category of CDF that you can play. So for example, if you're learning web application hacking, you can play the web application hacking category, and then they will give you a website that is vulnerable to certain type of attack. And the goal of playing CDF is to exploit the vulnerability that exists in the website. And if you find the vulnerability that exists in the website, they will give you a piece of secret number. And if you find that piece of secret number, it means that you won the CDF. And most CDF is a tournament that if you earn some certain point, you actually got some reward like money or clothes or something like that. And another thing that I would do is to and the final one is that if you already learn and practice, you can you want to try to hack the real world target without illegal, without getting you in trouble. Because if you're hacking other people website without permission, you would get into trouble. But in this case, you can go to HackerOne, which is basically a third-party man that coordinate between security research to the company. So for example, if GitLab have a application security program that they want the people to test their website and find if the website is vulnerable to some certain type of attack. And there also a limit scope that you can test GitLab website and without actually get into trouble. For example, you can only test this functionality that exists in GitLab or GitLab.com. If you are testing the function outside the scope, you can get into trouble. So if you find that vulnerability in GitLab.com and you report to them and they verify the fix, you can actually get the reward depend on the vulnerability, the impact of vulnerability that impact to the services. For example, you found a high impact, like you can able to view other people private data, it probably rate as critical, and they will probably reward you about $20,000 to the max amount. So these are the lists that a lot of people actually found vulnerability on GitLab and report to GitLab, and when they find the fix, implement the fix, and reward them with the money. For example, like steal private object, which is basically an IDOR vulnerability, right? So yeah, that's all. Thank you. That's the end of my presentation.
Yes, thank you so much, Mr. Rattanak. That is really great and really interesting. I hope that some days you can join my development to improve the security. Yes, so everyone, do you have any question? It is really interesting topic, honestly. Really great knowledge.
Okay. There is some type of another vulnerability that I'm not talking about because of we have too much time, but this one is actually interesting and also could impact a lot to your web application because of this vulnerability exists in the proxy, like proxy, the back end, and the front end of the application. So yeah.
Hello, Rattanak.
Yes, yes.
I have a question related to the HSS. You show us we can set the content security policies, which is the focus on the script. Yes, and I see we set the content security from our own domain, like you say the local or with the port ATT or another own domain. Is it mean our JavaScript file stored in our source code is our by own, but if we use the JavaScript as CDN, is it can protect also, right?
So if you want, if you have your own CDN and you upload all your JavaScript file to your CDN, and you want to basically tell your website to execute the JavaScript file from the CDN only. If there is an attacker that inject their own JavaScript from another website into your web application, recheck it. So if you want to do that, let's say, you can specify here, you can specify instead of jsexample.com, you can specify your own CDN to like cdn.yourwebsite.com like that. So when your application pull the JavaScript from the CDN, is actually execute that JavaScript file instead of blocking it from execute. Yeah.
Okay, it means that we have to tell the exactly CDN link file with the script SRCs.
Yes. Yes.
Yeah.
You have to
Okay.
do that because
is it beside this CDN link, the security it will reject the script pull.
yes, yes. Because if you have a complex application, you don't know if that some functionality in that application access. So in order to if prevent it from vulnerable, you have to use content policies header, because if the attacker can find some function that vulnerable to XSS, but they still cannot execute JavaScript. So what the point, right? Yes.
Okay. Thank you. Yeah, thank you for your answer. Yeah.
Yeah.
That's all for me.
Then let me ask you one question. Actually, it's not about the technical things, but when did you study that security things in your project or personally?
I about like 2 or 3 months ago, because I when I interested, I start to go to the resource that I recommend to get started, and then I start to learn about those vulnerability and play some CTF. So that's how I get started. Yeah.
Yes, thank you. Great. And yes, especially in our infra team, we should understand that security things more and more. Yeah, thank you so much for this presentation and some guide to start and get it started. Yeah, really, thank you so much, and a really interesting topic for me.
Yes, thank you.
Yes, I would like to join some question also. One dependency that you show, it's about NPC. Can you scroll back to that?
Yeah.
I have one question about the dependency that is really risky for our computer. What is dependency name?
It's called Node IPC, but right now the the mainnet is already revert the chain, so you can use it to install your computer right now. So this happened here occur about 2 or 3 months ago, because yeah.
Oh, I see. I see.
You might, but you don't have any way to confirm that this maintainer probably want to put the malware in the code anytime, because they already done one, so they probably done another time. So yeah.
I see. I see. Okay. Thank you so much. Mm.
Hello, Rattanak.
Yes. Hello.
I have one question. That if we want to develop a web application, like example, Django web application, and so what is your step, or what is the point you want to check, make sure the application is secure? It's just a general step we take to measure that our application is secure.
I think what make the application vulnerable is how the developer writing code. So for example, if the developer forgot to sanitize the script tag and allow the attacker to inject the script tag into their web applications, it means that the web application is vulnerable to XSS. So if you set up the application from scratch, usually not vulnerable to any certain attack unless you write the code that allow that vulnerability to happen in your application. For in the case like Django, and other popular framework, they already have their basic security configure already. So things like what is it? CF token. So in Django, they already implement the CF token protection already. But if you are using like HTML or JavaScript without using modern framework, you have to implement CF token by yourself. So, and in the case of React or modern framework like that, they already have a good security protection configure for you already. So so for you to do is not to write the bad code that allow the vulnerability to happen in your the web application. Yeah.
Yes, thank you for the step. And have you ever heard about a zero-day attack?
Oh yes, zero-day attack.
Yeah, can you explain something about it?
Zero-day attack, basically what I understand is that the vulnerability exists too long ago, but the software vendor or the user doesn't have knowledge about that it actually exists. So if the bad actor or attacker actually found a zero-day attack on your software, it means that they can use they can use it to exploit your system silently without knowing, without letting you know that they execute, they they hack your computer. So 0-day attack mean that the vendor has 0 day to patch the software because they don't know if the vulnerability or the vulnerability that exists in that software. Yes.
Yeah, that's nice. Thank you for your explanation.
Yeah. So for those of you who don't find who are really interested, there are many types of hacking, like software hacking or hardware hacking. So so if you are not find the web application hacking interested, you can try to start get into software hacking or hardware hacking. For the case here, can learn how to reverse engineer the software or clone the software, something like that, or play this sandbox CDF, which essentially target around hacking web browser. Yeah.
Okay, thank you so much, everyone. So do we have some time more? That's all from me. Yes. Yes. Is everyone have any question?
Maybe that's all.
Okay, one more. Let me add one more. Do we have more vulnerability beside the web application?
Oh, do we have more web vulnerability beside the
I mean,
vulnerability that I just talked? Yeah, yeah.
Not directly to the web application.
Yes, there is another web vulnerability beside web application. So in the case of software, there is some like buffer overflow vulnerability or heap overflow vulnerability that exists in the software, so that you can use the web vulnerability like XSS on the software. You have to use another type of vulnerability that exists specifically for the software. And in the case of hardware, there's also another vulnerability that exists on the hardware also. And the way on how to test for it and how to fix it is also different from the how we fix in the web application also. Yeah.
Yes, I think cybersecurity is a very big topic.
Yes.
Yes.
So there is another resource that I would recommend or tip. So if you want to look for a resource that is related to security, you can type Google for awesome security. And then you can see a list, the result. And here there's a list that people curated. So if you are interested in security that appear in Docker, you can click on and they will recommend the resource that you can get started with, like conference or talk of another people. And it doesn't have to be security. It can be related to a certain type of technology. So for example, you want to learn React, you can type awesome React. And there you go. There's a resource that you can get started with, things like popular library that used for detecting location in React. And there's a ton of that, like just learning. Awesome machine learning. Yes. So yeah, that's basically the tip that I can give you if you want to learn something, but you don't know where to look for resource. Yeah.
So this repository
Nice.
owned by person, just one
Yes,
person.
yes, just one person. So this person here is find the resource, and then they put it together into their repo, and people find it and go to that link by that repo. Yes.
Mhm. Oh, great.
Yes, that's all for me.
Okay, everyone, do we have any more questions?
And Rattanak, do you have a experience to secure the infrastructure, network infrastructure, maybe network also vulnerability?
Yes. I don't really much experience in the infrastructure. I mostly have some experience in the web and the software type of thing. Yes. So yes.
We already heard about router like Cisco device. Any network device can also under attack.
Yes. That is look, that is what we call hardware hacking. If we can, yeah.
Yeah, many topic.
Yeah.
Okay, everyone, thank you so much. So, yes, by the way, I hope we can access the presentation slide. Yes, yes, I saw that you put on the sheet already, and we can access and review more. Okay.
Yes.
Yes. So that's all from me. Just let's move to Yoshida-san. Is there any?
No, you don't need to move to me. You can close meeting by yourself.
Okay. Okay. Thank you so much. Hope have a nice weekend today.
Okay, have
Yes.
a nice weekend.
Okay.
Thank you.
Bye.
Bye.